You just wait. Can expand, condense logarithms.
You got a YouTube channel?
Yeah, I'm famous, so.
I actually saw that yesterday where I was doing my notes.
Yep.
Do you put videos on there?
I post these notes. I'm gonna get a lot of subscribers. Oh my gosh. Yeah. Okay, so this is the last section. Tomorrow we're taking a quiz over section 2 and 3. So, we're going to use our product property, quotient property, power property from yesterday. So we're going to expand this. We're going to make as many terms as possible with our logarithms. Then we're going to condense it to get into one logarithm. Hi, you seem very enthused. Bye. Okay. Alright. So, we're going to expand this. So, if I'm looking at it, I would figure out how many parts there are in this logarithm. So, if I'm counting it, 3 is part, x squared is part, y is part.
Is 3 a big number?
A big number. Yeah. It's base 10, and I didn't write the base with it. Okay, so if there's 3 parts in a logarithm, I can break this into 3 different terms. So this is a product, so our product property says I can break this up into a sum. So that's what I'm going to do first. So I can write it as log of 3, and then plus the log of x squared, and then plus the log of y. Oh, okay with what I did there. Product is sum. Okay, so then our final answer shouldn't have any exponents with it, so I can move this 2 up here in front of everything. So log of 3 stays, because I can't simplify that anymore. But the 2 for log x squared becomes 2 log x.
What was that? There's probably
Like log of 3x squared y. Okay, so this is as expanded as possible. I can't expand anything else. Every logarithm has just one part to it. There's no exponent, so then we're good. Very good, Trey.
Mm-hmm.
Okay. So this one reads log base 2. The square root. Oh gosh, let me start out of root. The square root 4x plus 1, and then over 8. So this logarithm is of this whole fraction. 2 is our base. I would like to expand it to write as many logarithms as I possibly can. So what property would we probably use first? Yeah, the quotient property, so rewrite the fraction as a difference. So log base 2 of the square root of 4x plus 1. And I can write it as a difference, so minus log base 2 of 8. Okay, so that's using the quotient property. I can keep going with this. How can I rewrite the square root symbol of the fractional exponent? So we were doing that yesterday with our fifth root thing. Oh gosh.
Oh, to make it 2
2 lost like that.
I'm gonna have 4x plus 1 without a square root symbol. I'm gonna put an exponent with it.
Yeah.
But I need to figure out what the exponent is for my square root symbol. So I technically could write 4x plus 1 to the first power, what's underneath the radical. And there is a 2 sitting here, even though it's not written.
2.
It's a fraction, I think.
1 to 1/2 power.
1/2 power. Yeah. 4x plus 1 is raised to the first. The root is the denominator of the fractional exponent. Okay, so that's rewriting the square root symbol. If I'm looking at log base 2 of 8, you should always try and think if it's just numbers, can I simplify that at all? So basically, can I rewrite 8? So that has base 2, so that's my logarithm.
2, 3, 4.
Get rid of
To the third, I heard. Yeah. So 8 is the same thing as 2 to the third. That way I can see I can simplify this down. Right, so now I can move my exponents in front using the power property. So I'm going to do that too. So 1/2 log base 2 of 4x plus 1. And then minus 3 times log base 2 of 2. Yeah, so this log base 2 is just 1. So technically, I have this. Then just minus 3. Yeah, this 4x plus 1, I can't do anything with it. It's just kind of like its own piece that's in parentheses. So we can't combine the 30 and the 1 together or anything like that. It's just, that's it. Expanded. Beautiful. So I wanted to do a more complicated one, and this is my complicated example, which is over 15 minutes in the textbook. Ready to start?
That's 2 to the 4.
Yes, the fourth root.
natural log x. History. So x.
I sit in on this. I was trying to help Austin with this.
Oh, fun. Logarithms? Yeah,
Hate 'em.
we're expanding.
Yes.
I don't actually want to distribute underneath the radical. I just want to work with it.
Alright, so x to the third. X squared plus 3.
Yeah, so rewrite the root to the 1/3 power. So that whole thing is to the 4th. Okay.
Oh my god.
Okay, bye. Whatever. Okay, so now I can move the 4th in front of this natural log using the power property. So 1/4 natural log of x to the 3rd, x squared plus 2. Alright. I can keep breaking this up. What? Oh, well, it's not like it's speed, that's what we can make it.
How did we use the 1/4?
Because that was the 4th root thing. Because, yeah, this whole thing goes to the first power. I can break up the x to the 3rd and the x squared plus 3 part. The product. We separate it. So the 1/4 is for everything, so I'm going to put brackets. But if I'm separating these two things, since it's products, I can rewrite the logarithm as a sum, the natural log of x to the third, and then plus the natural log of x squared plus 3. That was a product property. Then whenever you have parentheses around something like this x squared plus 3, that's just them because it's not raised to a power outside of parentheses. So I can't do anything with that, but I can work with the natural log of x to the third power. Yeah, I can move the 3 in front. So I put 4 times the 3 natural log of x, then plus natural log of x squared plus. So this is as expanded as possible. I could distribute the fourth to like each term, but you don't necessarily need to. You could if you wanted to. If you're thinking about that. But yeah, these are just kind of weird. Okay, now I want to go the opposite way. So now it's going to be in expanded form. And we want to try and condense it so there's just one logarithm written. So like this guy, I have 2 logarithms written. I want to put them together into one. So this looks like 1/3 log of x plus 5 log of x minus 3. So I guess if I was condensing, I would probably do the power property first. So like move all the exponents where we need to go. Yes, so it's x to the 1/3 power. Right. So 5 comes with the power to that binomial. Okay, how do I move it over there? What property is that? Product. Yeah, so we're going to write it as a multiplication product. So log of x to the 1/3, then times x minus 3 to the 5th. So I got rid of 2 logarithms, condensed it to 1. I want to simplify this just one little more piece. If that's a phrase. How can I rewrite the 1/3 power? So instead of fractional. I'm gonna write it as like a root system.
The third root.
Yeah. 3rd root of x, and then times x minus 3 to the 5th. Yeah, so this is condensed. Everything's back where they need to go. 1 logarithm. So this is good. Okay. I think we have this one and then one more. And the next one is what's all one. Okay, so where do we start? Okay. Sweet. Now what?
Derivation.
Yeah.
By the x squared.
Right, so I can condense it to 1 logarithm using the quotient property. So I can write it as a fraction. With 1 natural logarithm. Yeah, that's it. I can't condense that anymore or simplify it, so that's just going to be done. Woo! Okay, so here's this one. It's 1/5.
This is the last one.
Yeah. Log base 3 of x plus log base 3 of x minus 2 plus log base 3 of x minus 1.
There's some numbers in
Okay.
Here's some numbers in my letter. Yeah, we got more letters than we do numbers.
Okay.
The first one, one is
Okay. Yes, I can move the 1/5 up. Yeah, it's gonna go outside of the bracket. So log base 3 of x plus log base 3 of x minus 2 bracket to 1/5. Nice.
Or could you square root? Would you need to square root to the 5th root? That
Yeah.
whole thing to the 5th root.
Yeah, I want to do that, but I want to write it in one logarithm first before we do that. So instead of brackets, I can
Oh,
do
so
that.
use the product.
Yes. So since it's a sum, I can write it in the top log base 3 of x, and then times x minus 2. 1/5. Salisbury steak and mashed potatoes. Okay, so now we have one logarithm, so we can do the 5th root like you wanted. We have log base 3, and we're 5th rooting this whole product, x minus 2. And I still have that log base 3 of x minus 1 trailing. Okay, and then we have one last step. I still have 2 logarithms, so I want to condense to 1 logarithm. So I'm not going to put these together. Right. And I'm going to write x minus 1 in front of the whole thing. So x minus 1 and then times the 5th root. X minus 2. I guess it probably doesn't matter which way you put it, as long as I can clearly see x minus 1 is not underneath the root symbol. But yeah, this is as condensed as we can go. That's the complicated one. Okay. Quit smart over logarithms. Woo.